Have you ever pondered over the question how machine learning algorithms handle large data sets? How do they sift through the sea of information and make sense of it all? Well, one of the secret weapons in their arsenal is a technique known as factor analysis. Factor analysis is a method used for dimensionality reduction. But what does that mean? Imagine you have a large data set with hundreds of variables. It's like a vast, intricate landscape. Now, wouldn't it be simpler if you could view that landscape from a higher vantage point where you can see the bigger picture, the overall patterns? That is exactly what dimensionality reduction does. It simplifies the landscape without losing the essential features. Factor analysis is a statistical method that describes variability among observed, correlated variables in terms of potentially lower number of unobserved variables called factors. It's like a translator, translating the complex language of data into simpler, understandable terms. So, how does factor analysis work exactly? It can be broken down into 4 fundamental steps. First, it's all about the correlation matrix. This matrix measures the linear relationships between variables. Think of it as a social network of data where each variable is a person, and the correlation matrix tells you who is friends with whom. Next, it's time for some extraction. Based on the correlation matrix, factor analysis extracts the factors, which are the underlying dimensions that explain the correlations among variables. It's like digging for gold, where the gold is the factors that help make sense of the data. The third step is rotation. The extracted factors are rotated to a more interpretable structure. Picture spinning a globe to get a better view of a particular country. Similarly, rotation helps in better interpretation of the factors. Finally, it's interpretation time. Each factor represents a particular dimension in the data. These dimensions are interpreted based on which variables they are highly correlated with. It's like deciphering a code, where each factor is a piece of the puzzle. Now you might be wondering, why use factor analysis? Well, it's a powerful tool for reducing the complexity of data. It can help in data pre-processing, exploratory data analysis, and even in building predictive models. But remember, factor analysis makes several assumptions. It assumes linear relationships among variables, and it assumes that any observed variable is directly associated with any factor. Also, it's not the only dimensionality reduction technique out there. Depending on the situation, other techniques like principal component analysis or independent component analysis might be more appropriate. In summary, factor analysis is a dimensionality reduction technique that transforms a large set of variables into a smaller one, without losing much information. It's a way to simplify the complexity of data, making it easier to understand and work with. It's a key tool in the machine learning toolbox, helping algorithms make sense of large data sets. So the next time you marvel at the capabilities of machine learning algorithms, remember the role of techniques like factor analysis. It's through such methods that these algorithms can navigate through the vast landscapes of data and uncover meaningful insights.